Day 11. Is it better than 7? Hi and welcome to another episode. And what we've got here is the PiHut Advent Calendar, the 12 projects of Codemas. And we're on to day 11. So let's have a look what's inside. Oh, I know what it is. It is some more jumper wires. Not like we haven't already got loads of them. Come on. Why are some of these bags so difficult? Give me in. Right, here we go. Let's say more jump. Oh, careful. Pins out. More wires. And we have a tiny little screen. Now, I can't remember. I think these are OLED ones. Tiny little screen. I've got one of these in a GoTech. That's what I've got it in a GoTech. So they can come in handy. But let's have a see what we're going to be doing with our wonderful Pico, which is all this rat nest of wires and stuff. And yesterday he told us that we're going to basically just strip down to the bare necessities and put the LEDs back and all that wonderful stuff. So let's see what they actually do say. Right, so it says OMG OLED, which is nice because OLED's nice little screens. But let's scroll up and have a look. Scroll down. I keep saying scroll up. Scroll down. Welcome to the day 11 of your 12 projects of Codemas Advent Calendar. Today we're playing with the really fun and useful component that you'll use again and again in your projects. A mini I2C OLED display. Oh, whilst only teeny tiny, these little displays are great for showing data for your project, such as sensor readings, scores, pin status, alerts and other useful information. We're going to combine it with some components from earlier boxes to show you just how handy these are. Let's go. A pre-soldered 0.96 inch OLED I2C display, 128 by 32. Is it? Is it really? The male-to-male jumper wire. Some will know my questioning of that compared to the display that we got in the other Advent calendar. Anyway, today's project. Today we are going to display data on our mini I2C OLED display. They're relatively easy to code, but they do require installation in a library which we import at the start of our program, but would guide you through this. What is an OLED? The display in your box is an OLED display. OLED stands for Organic Light Emitting Diode. You may have seen this mentioned on advertisements for TVs and many other models use the technology. It's a type of digital display technology that uses LEDs and layers of thin organic film between the two electrodes. When electrical current is applied, the display emits light. Our code tells the display where to show light and when. What is I2C? I2C is referred to as IIC, stands for Integrated Circuit. It's another type of communication protocol. Remember the one wire from day number 8, which allows multiple I2C devices to communicate to a controller like a Pico. I2C requires just 2 wires to communicate, along with a 3.3 volt and the ground for our display, and has benefits over some other communication options, but we won't bore you with all that just now, as it's not going to be relevant until we're much further along in your maker journey. To use I2C, we need to import it in our code, which we'll show you in just 2 ticks. Oh, just 2 ticks. Right. Construct the circuit. First, disconnect your Raspberry Pi Pico from your PC. Okay, we've done that, haven't we? That's been done. Ensuring the power went down. Today we finally removed the LEDs and the buzzer as input components like buttons and sensors are more relevant and useful in this display. If you haven't already, remove everything so that you're back to a clean breadboard, just your Pico fitted like this. Okay, so let's put box 11 away and then get out, it was box 2 for the LEDs, wasn't it? So let's open that up. Just so when we go looking back over it again, pull all 3 LEDs out in one go. All these resistors in one go, because these resistors are the ones that match the LEDs, and we don't want to confuse them with other ones. I realize we can look it up. Basically, if you don't know about resistors, there's little lines on them of different colors, and when you hold it the right direction, you'll be able to figure out, compared to a key, basically, which is a little graph of what the colors mean, and basically, depending on where the colors are on the lines or the stripes, and where, depending on the color and depending on where that color is on a particular stripe and what the very last one is, will tell you the value of the resistor. So it is possible to figure it out again, but you might need to get a magnifying glass out, and you definitely need to go find a table or a key that explains what's what. Anyway, that's something for you to do, just in case you didn't know about resistors, because I know there's plenty of people out there that know far more about electronics than I do, which is probably plenty of people, but also some people are maybe a little bit in the newbie queue than I am. But we all have to start somewhere, and we all have to take the journey as far as we're going to take it, don't we? So let's remove all the wires like it says. Basically, I'm going to cheat a little bit and just leave all those wires in the mini breadboard until it tells us that we need the mini breadboard. Until then, we've got our Pico just the way it says. I'm going to close up box number 2 so I don't lose them. Let's scroll down. Next, fix one of your buttons on the OLED display into the breadboard like we have below. Make sure you leave a gap above both for us to add jumper wires. You may also want to peel off the display protective film at this stage. Okay, let's find a button in this little pile of bits. We're going to add it so that the legs are top and bottom, and we're going to put it that the top left leg goes into B30, and all the rest slot into place where they're going. There we go. So the pins should be in like B30, B28, what's that one there? E30 and E28 for our button, and then the display. Let's peel off a little protective bit. Got to be very careful though, we don't want to scratch it. They are quite, you wouldn't want to sit on it, you wouldn't want to stand on it because it would cause you damage, but also you would easily crack it. And try not to touch the screen because it is a thumbprint magnet. So the top left pin of this, we're going to stick this in B25. I believe that's where it wants to go anyway. Be careful, don't hurt yourself. And that should be where that sits. So it's in the, oh no, it's actually the row above, isn't it? Oh, it shows it in being B. If I put, that's weird. I swear blind it was in B before. Okay, I need to take my Pico back out again. There we go. If I had it wrong all this time, I've not even noticed. Oh dear. Anyway, the Pico, I've got that in the C row for the top row. The OLED is in the B row, and I've got my button in the B row as well from, top left. So it's like for like now, definitely. Can't believe I've completely missed that all this time on day 11. I haven't seen. Nobody told me. Next, we'll add the 3.3 volt connection. Run a jumper wire from 3.3 pin, physical pin 36, to the upper red channel, then connect the left button pin to the same red channel, and the second OLED pin labeled VCC to the same channel as well, like below. Right, so let's get some red wires. We need 3 of them. Let's not confuse these red wires, but we'll steal one from here. I've got 2 red wires, 3 red wires. Again, the color of the wire isn't going to change the functionality of it, but it will change, well, you understanding what's going on. Right, so A30, putting that to the top row in the red. Should we zoom in a little bit so we can have a look? A super fast zoom. Calm down, calm down. It's far too fast. Oh no, we're going to crash. No. There we go. Right. And then we want the VCC, which is second pin, which is A24. We want that to go to the top row in the red area. There we go. And we want pin 36 to do that. So I think we already know what that's going to be, but let's count it. 40, 39, 38, 37, 36. As we already guessed, it's J5. And we want that going all the way across to the top right hand corner of that red line. That should be us done now. Next is our ground pin. Connect the first OLED pin labeled ground to the nearest ground pin on the physical pin 18, like this, or like we have below. Right, so a black wire. Take that from the ground, which is, where are we? A25. Definitely gonna have to start wearing my reading glasses more often. Had them for over a year and I've worn them like 5 times. Right, and then pin number 18, which is A18, because we know that because that top row is 1 to 20. Right, so there we go on that one. Now, for the 3 GPIO pins, which will talk to our Pico, connect the right button leg of the to the GPIO 8 or the physical pin 11. Now we don't have a purple cable, so let's just pick one that they haven't got going on there. So let's use a yellow wire. There isn't so many multicolored ones in this set, is there? Right. So I keep saying so, but it doesn't really matter. Top right pin of the button. That's pin A28 across to pin 11, which is easy to count, A11. Then we want a label from the SCL to GPIO1, physical pin 2. We've got any white cables on the go. Let's use a white one. The VLC, which is pin 23 across to pin 2 on the A bit, and then we need a green wire. We don't have any green wires, so I don't think we do we? This is where it all gets confusing because they've not given us like a spectrum of colours or a rainbow of colours. What shall we grab? Do we just grab another white one? I'll be careful with this though. Actually, let's use a yellow one again, just to make sure that the colours of what are on the OLED are different. All those pins are different colours. Right, so we take our yellow from there, and that needs to go all the way to physical pin 1 on A1. Okay. Now we should be wired up. Can we see the screen even though there's wires all over the place? Oh, they'll bend back into shape. I'll bend them out of the way when we actually come to using it. Oh, we do need the little mini board now, it seems. We'll be using a light sensor from box 6 in our example today, so we need to wire that up as well. We'll use our mini breadboard for this. Fit the light sensor and the 10k resistor into the breadboard, or we'll use it below. The long leg of the light sensor needs to be to the left. Oh great, which one's this? We only got the one resistor, I think we have. Any other resistors? So as much as I was telling you about well, one, maybe putting them back in the boxes in the first place instead of just leaving them in a pile. Now we learn the hard way, don't we? I'm just going to double check that this in fact is a 10k resistor. So what can we do to do that? Well, I zoomed in, zoomed out, trying to get the camera to look at the resistor so we could have a look at what the colours are. It just won't focus properly for it. So what I've done is taken a photo, which I'll show you in a moment. There we go, I've zoomed in, taken a photo. And what you can do is either look for a website that tells you, or what you can do is install an app on your phone and you can plug the colours in. So what we've got is brown, black, black, red, and the tolerance is 1%, and it gives you the value just in the top right corner there. If it just try to get to zoom in, is it going to do it? Come on, phone. There we go. As you can see, 10k, 1% tolerance. I just tapped in it all in and it tells you the results. And if you've got the other types of resistors, the ones that are sort of more creamy looking, you can tap that, or you can tap the site. Now obviously this is an iPhone app, it was free, I didn't have to pay for it, but there's like apps like that as well for Android. So don't worry about, you know, stuff. I, as a nerd, once upon a time, oh so many years ago, learned that whole table off by heart. It helped me pass my GCSE, but it's not something you really have to do nowadays. You can just figure it out by using technology. In the meantime though, I know I've got the correct resistor, so let's move back to the fun stuff of getting on with this. Sorry, that's a bit of a palaver for making sure, but I wanted to make sure I got the correct resistor so I don't blow anything. Right, now wire up the light sense. Well, sorry, we need to get this. Oh, I have jumped ahead of myself. Take all this other stuff off. We want to put that resistor on the fourth hole across, and then it wants to be 1, 2, 3, 4, 5 away from there. Not that it really matters, but it's just so that you do everything the way it's supposed to be. So yep, leave 3 holes in between, and we want the left leg to the side, and on the same column as the right leg of the resistor, we want to put the left leg of the sensor. I'm assuming it's this one that they want, not the movement thing. We'll put that in. So that's there. And now we need to do the wires. Really wish they had given us more multicolored wires, but so be it. Let's get a red one and a, no, let's hold them. We need a black wire, so that's fine, but we want a white wire. I'll steal a yellow one from somewhere else. Right, so we've got all the 3 cables we need. The black wire, which is the ground, we need to take that from the left resistor, so 2 down from the left leg of the resistor, we need to take that to pin 28. So we know this down here is 21. Let's zoom back in yet again, because I forgot that I was zoomed out. Right, so we've got 21, 22, 23, 24, 25, 26, 27, 28. I want that on the bottom row, so that is in fact J13. And we're going to take our left leg, sensor leg. So we need a yellow wire, and we're going to take that also from the 3rd row down on the mini board in line with the right leg of the resistor and the left leg of the sensor, light sensor, and we're going to take that to GPIO 26, which is physical pin 31. So we know that one was 28, 29, 30, 31, and we know 31 is J10 from all the times we've done it in the past few days. And then we get our red wire, wherever I've put that now. What did I do with it? It's very blind, I had a red wire. I'm losing my marbles. Right, red wire. We take that from right next to the resistor, which also happens to be the right leg of the emitter in the realms of the columns and stuff. So we take that and we want to stick that in, actually we want to stick that in J5. So the one that I put already in, that needs to move up one to I5 and stick this one in J5. It wouldn't really have mattered which way around, but let's stick to what we're doing. You should have told me I made a mistake again. I think I'm getting a little bit with circuit boards, doing so many of them in a short period of time. Right, let's move on to the next bit. Now turn your breadboard 90 degrees so that the OLED is facing you. Okay, there's 90 degrees. I hope that is it facing me. This will make it easier to view and read the text as we show it. Okay, so we're going to do that then. Let's bring the USB cable over here so that it tries not to rotate it around. It's all a bit of a jumble now, isn't it? Can we zoom in even more, because you're going to be interested in what's happening on the screen. There we go, that's close enough. Install the code libraries. Plug your Pico back into your computer's USB port to make sure it's recognized. Then let's install what we need to make it work. Oh, they finally tell us to do it again. Right. Been banging around trying to get my fancy USB port. Make sure it's all on screen. There we go. Been hitting lucky for the past couple of days of getting it right the first time around. There we go. I'll try to keep some of the wires out of the way. Let's put a bit of pinch in that one so it stays over there. Ah, it's just not going to do it, is it? Come on. That'll do. That'll do, Shep. Right. Install code libraries. Plug your Pico back into your computer USB port and make sure it's recognized. Okay, I've already read that, but let's make sure it's recognized. Right, it's recognized. And then let's install what we need to make the display work. Our display needs a code library package that isn't included in the MicroPython by default, so we need to install that before we can start using display. We will then input this library and when we write our code. Luckily, there's a very easy to do and all handled within Thony. So let's get it installed. The following may vary slightly depending on the type of computer you're using. I guess if you're using a Mac or something like that, I think that's what they're getting at. But I'm going to read out the Windows bit. If you're doing something a bit different on a Mac, then, you know, if you have any difficulties with it, please say so in the comments below, and I'll see if I can try to help. I don't actually own a Mac modern enough to say anything really, but I can guess from what I know about from Macs. Anyway, important. If the steps below don't work for you and you see certificate errors or other similar messages, you may need to install library manual. Right. To do this, go to this link, select all the code on that page using Control-A and copy it over to Thony. In Thony, save as. Okay, right, let's go grab the code first. So what I'm going to do is right click, select all, right click again, press copy. Then I'm going to go back to what it's saying to do. In Thony, so I copy the code into Thony, paste it. Now we need to click File, Save As, click Raspberry Pi Pico, click, and then we need to save it as SSD 1306. So SSD 1306.py. Click OK. And that's it, it's flashed it towards the Pico now. Click OK and everything. Important, you must now close this SSD 1306.py file and use little X on the tab. Then open a new one if you're for your code, file new, otherwise you'll be overwriting that file and making it a big mess of it. Okay, so let's close it. It says press the little X on the tab, so boom, gone. Start a new one. You can click File New, but you can also just click that white page there. Let's move on to the next bit. In Thonny, from the top menu bar, select Tools, Tools and Manage Packages. You should have something in the box. Tools, Manage Packages. You should see something familiar, something similar to the box below. Okay, in your search bar, enter MicroPython-SSD1306. Okay, so MicroPython-SSD1306 and click the search button. Right. You should see results like we have below, including the MicroPython-SSD1306 module we need at the top of the list. Okay, that one. Select that line to go to the information screen for the module, then select Install button on the bottom. Right, so we click that, then we click this Install button. Downloading. So if we uninstall pip-zip, it's doing stuff. It's all doing this all in real time. There we go. It's now obviously added something. All right. So we click to install. Once the package is installed, it will show on the install packages list on the left. It is now ready. So there we go. It's here. They seem to have installed other stuff as well, but that's what they're getting up to. So now we can just click close and get on with reading the activity for today. We'll start by showing a single line of text on the display to kick things off. Of course, it'll be a traditional Hello World, the I2C and display setup. To use this display, we need to import I2C as well as the library we've just installed. You'll see this in the first few lines along with the other imports as well. We then need to set up an I2C and the display, which we will see in line 7. This includes the GPIO pins. We're using GPIO 0 and GPIO 1, which are the SDA and the SCL pins used in the I2C connections. After this line, we always have to wait around 1 second, otherwise I2C can get all stroppy and fall over. I do love 3-letter acronyms, or 3 LAs. Next, we need to define the display size in pixels and the type of driver chip it uses. Our display uses, surprise surprise, an SSD 1306 driver and is 128 by 32 pixels, which is reflected in line 13. That's all the setup out of the way. Displaying text. When we want to display something on the display, we also go through the same process. Clear the display, define the content we want to show on the display, push the content to the display. If we don't clear the display every time, it will write the new content on top of the old content, which makes a big mess and jumbled up characters. No good. Our example shows us clearing the display with display.fill0, then sending hello world with display.text hello world, 0, 0, and finally pushing this to the display with display.show. The code. Okay. We'll cover what the 0, 0 arguments do in the next activity, but for now, copy this over to Thonny and see for yourself. So, as I always say, when it comes to the code and everything, you should tap this out yourself. The drivers and libraries and stuff like that, by all means, just copy that. I don't expect you to type that out until you want to start learning how to create your own libraries, which is way above the my knowledge and also how far these things take you. But the programs themselves, though, I recommend you type them out. Right, so it's pulling in the libraries. We know that's what it's doing. It's talking about I2Cs. And then it gets on with doing stuff, doesn't it? So let's run it. Hello World is displayed on our little OLED screen. Look at that. Hello World. It's a little bit out of focus, but that's to do with my camera, I think. Zoom in a little bit more. I think it's just the way that the camera is doing it. For me, it's a nice clear screen. It seems to be white text on a black background, not blue, but black. At least mine is anyway. What colours are yours? Because they do come in different colours, these things. Alright, move on to activity number 2. Multiple lines of text. Let's go one step further, adding more lines and changing the position of the text, but first let's cover those arguments. You'll notice that there are some arguments, 0, 0 after the text we push to the display, which in this case is display.text hello world, 0, 0. The first argument determines the pixel across the display content should start at on the x-axis, and the second argument determines how many pixels from the top the content should start at the y-axis, going downwards. Our display is 128 by 32 pixels, so we have 128 pixels running across the x-axis and 32 from top to bottom on the y-axis. In our example program, we managed to squeeze 3 lines of text onto the setting of each one of a different height, which just takes a bit of trial and error. The first line is at 0, the next line is at 12, and the final line is at 24. If we add more lines, they won't be fully visible. We've also moved line 2 over to the right by entering 50 in the first argument, again just with trial and error. Give the example below a try and then play with the argument values to see the changes for yourself. Okay, what I'll do is leave you to play around with the changes because this video is getting a bit long, but let's play around with the code and copying it across. So here we go, they've moved it around a bit and everything, and let's run it. There we go, so line 1, line 2, line 3. So we can fit 3 lines of text on, which is nice. Activity number 3. Small LED displays are great for displaying data and they can refresh quickly enough to show data changes at a very fast rate. Let's create an endless, well, kind of, counter to show another way of using these displays. When you come to make your own projects, things like this will come in very useful. We don't use a physical inputs here, just a counter in our code that increases by 1 every loop. The code, a new problem. Our counter is a number, an integer, but our fussy little display only shows text, a string, so we need to convert our counter to a string every time we run the loop. Converting integers to strings. We convert the count integer to text string using the following line: display.text, bracket, bracket, str, bracket, counter, close bracket, comma, 0, comma, 24, close bracket. Oh dear. So instead of entering text in brackets like we did in the previous activity, we use bracket, str, bracket, counter, close bracket to turn our counter variable into a string for our display. In other words, quite straightforward, adding the +1 to our counter at the end of every loop to continually increase it. You can play with the time delay within the while loop to see just how fast it can run. Okay, don't forget to play around with moving things around in the last one before you start doing this, but let's get this code in. Counted. So there we go, it's counting away very scarily, fast speed, letting you know that if it was going the other way, you really need James Bond in the room. Right, so let's stop that so that we don't get too bored. Actually, let's just leave it, shall we? We'll start again from 0. Doesn't really matter, it's doing that. Right, activity, the naughty or nice game. We're now going to create a game that decides your festive fate. Let's make a naughty or nice game which will tell you if you're a good list this year or not. Don't worry kids, it's just a bit of fun. We're sure you've been good this year. Have you? Have you? That's including the more grown-up kids as well, by the way. I mean, how many of you have actually clicked the links? Huh? How many of you subscribed? Anyway, this project shows naughty and nice with a marker that will very quickly switch between the two. When you click the button, it stops on whatever option the marker is at the moment. Your aim is to land on nice. The code. Our example below uses all our user ingredients, imports, display setup, buttons, pins, and creates a state variable, which we've used before. We use this variable to switch between 2 if statements within our while loop. But why do we want to do this? We want our display to constantly move the greater than marker between naughty and nice. To do that, we have 2 if statements which are triggered by our state variable between being either 0 or 1. Each if statement starts by showing the text with the marker of a different position. If the state is 0, the text pushed to the display shows the marker on naughty. If the state is 1, the marker is on nice, which is each if statement also changes the state so that on the next loop the other statement will trigger, which makes the marker jump between the two. Each of the if statements then has a nested if statement inside which checks to see if the button is pressed at the very moment. If it is, the code inside updates the display to confirm which option was selected, followed by a 2-second pause. Right, let's get on with copying this code across. So we stop it, close that down, get rid of it, start a new one, copy the code across, press paste. I'll let you look at the comments to see how to learn how things are working. I'll print, get it going. So the greater sign, basically the prompt. For you, it might look like it's near enough, just sort of flashing in between the two. It might even just show that it's always on for the two. It depends on how fast the camera's picking it up. But for me, it is going left, right, left, right, left, right, left, right, depending on the naughty and nice. So, where's my button? Button's there. Yes! I'm nice. I'm not playing that one again. Best out of 1. Right. So hopefully I get some nice spreads this year. Let's move on to the next bit. That's quite a program there. Okay. Activity 5. Show me the light. Showing sensor readings on our LED is quite possible one of the most useful and fun ways to put the display to good use. We're going to run an example where we continually check the light sensor reading and push this to the display if we can show the percent symbol. Even if we show the percent symbol. The example below includes similar code from the light sensor box, day 6, and the same OLED display code and approach we've taken above, so most of this should make sense if you've been following along. The code. The same initial OLED imports and setup code is present, and we've added the light sensor pin setup back into linking it to the GPIO26 along with the required ADC input. We then start the while loop, which takes a reading from the sensor on line 25. Now this line does a lot of things at once, so let's break it down. It creates a variable called light, it takes a sensor reading, it turns the reading into a percentage, it rounds the reading percentage to 1 decimal place. We did something similar on day 6, but this time we're doing everything on a single line of code. We've avoided this so far as it can be a little overwhelming, but we're on day 11, so we think you'll be okay. We then push this data to our display. We use this first line on the display to show some simple text, and the second line to show the reading. Just like the previous examples, we have to convert our light variable to a string to allow the display to use it. We also add the percent symbol to the end. Copy the code below, over to Thonny and give it a go. So as always, copy the code, put that in, get it running, and there we go. It's saying that the variable is different one, so we've got it up on the Thonny giving readings, but also it's doing it on our little display there. Can we cover the light over? And suddenly it's dark. Right. Shall we get some mobile phone torchlight on it? Or flashlight on it, depending on where in the world you are. It's the same difference. There we go. Boom. Nearly can't get any brighter. So it works the way that I want it to work. That's good. And now we're on to day 11 complete. There's a lot to have said that we've completed today. So, aren't OLED displays just bags of fun? We've only just scratched the surface as well. There are a lot of clever ways you can use these kind of displays with graphics, fonts and other tricks, but we wanted to keep our activities relatively simple for beginners. You'll find a ton of resources and other examples on the internet that you can use, even have your own graphical tutorial, which can apply to these displays too, with a few tweaks to the code. I'll let you click on that and have a find out about that. Let's recap. What did we learn on day 11 today? We learned to wire the OLED to our Raspberry Pi Pico, introduced the I2C communication protocol, learned how to install packages in Thonny, learned how to code an I2C OLED display, including how to write the text to the display, how to write multiple lines to the text, how to alter the position of the text, how to display the sensor data on the OLED displays, and a few tricks like markers. We reused knowledge and components from previous boxes, such as state variables converting integers to strings, nested if statements, light sensors, and more. Okay folks, we're nearly at the end of the 12 days. Sad face. You can remove the circuit from today, as tomorrow is an entirely different kind of component. We can't wait. See you tomorrow. And I'll add on to that. Don't forget to go into the descriptions, hit those links for Patreon and Discord. Please, please, please do that. Don't forget to hit the like button, the subscribe button, and that notification bell so you can come back tomorrow and find out what is in box 12. But as always, happy gaming.